In this video, I'm going to talk a little bit about using the cross-multiplication technique for unit conversion. Not always the most efficient way to convert units, but what's nice about it, as I'll show here, is that we can use it to solve all sorts of different proportional reasoning problems. So in this first question, we're converting between hectares and acres. That's the imperial and the metric measurements for large areas. It's often used if you're buying a big plot of farmland or something. It might be quoted as acres in the United States or hectares in Canada. So how many hectares are in 7 acres? So I know most of you, and this is correct, we just do 7 divided by 2.47. Of course that works. But one way we can set this up is as a ratio problem. So the ratio of hectares to acres, it doesn't matter which one goes on the top, which one goes on the bottom, is always going to be 1 hectare is always equal to 2.7 acres. And therefore that means that if we want to figure out, well, how many hectares are 7 acres, we would put 7 proportional in the acre side, and then, okay, I want to figure out h. So we set up a little cross multiplication. The way I can solve these problems always, no matter where my variable is, I'm always going to know 3 of the numbers, and I want to figure out the 4th. So I'm going to multiply together the diagonal that does not include the variable. So that's 7 times 1 is 7, and then divide it by the remaining numbers. So 7 times 1 divided by 2.47, and then in one step I can figure out the number of hectares. Because it's a measurement problem, every measurement problem, my answer should involve a quantity. In this case, it's 2.8, and then also a unit. So in this case, it would be hectares. So that's one way to convert units. Again, maybe not the most efficient. Again, it doesn't matter if I put acres on the top or the bottom. I can do the same thing. So 2.47 acres is equal to 1 hectare. So as long as we're consistent, in this question, I know hectares, so I'm going to put the 7 on the bottom, and I don't know the number of acres. So I could use x to represent a quantity that I don't know, but I want to know, and then again, I multiply whatever diagonal does not include the variable. We've got 7 multiplied by 2.47. In high school, we often don't write the time symbol, and then I would divide it by 1. So it's 7 multiplied by 2.47, and again, my final answer is going to have a quantity. In this case, if I round it to 1 decimal, it's 7.3, and then a unit, which in this case would be acres. So that's one way, again, maybe not the most efficient way, but it is one way to reliably convert between any 2 units. What's nice about this is I can extend it beyond simple unit conversion questions to solve all sorts of proportional reasoning problems. So for example, let's say you're riding your bike pretty fast. I think this is pretty fast on a road bike, and you've done 18 kilometers in 48 minutes. And you're going to keep going at the same speed. How long would it take you to bicycle 25 kilometers? So we're comparing, again, 2 things, the ratio of distance to time. And so you're always traveling 18 kilometers every time you go 48 minutes. And so if I want to figure out how long it would take to bicycle 25 kilometers, well, 25 kilometers is a distance, so I'm going to put it in the numerator with my distances. And then I want to figure out a time, so I'm going to put my unknown variable, t, here along time. Again, I can cross multiply to solve in one step. I'm going to multiply the diagonal that does not include the variable, so that'd be 25 times 48. And then divide by the leftover number. Again, in high school, we often write division as the denominator of a fraction. And again, we can do that in one step with any sort of calculator. And so that would take you, 66.7 minutes, an hour and 7 minutes. What's nice about these is once we set them up, I could solve for distance, I could solve for time, as long as the ratios, the proportions are equal or equivalent. I'm going to do one more question. To kind of show another kind of interesting thing that we can do with the same strategy. This is a kind of a real-life engineering problem. If you're making cement, one of those mixer trucks, cement is created by mixing sand and gravel in this ratio by mass. So every 5 kilograms of sand, I'd add 4 kilograms of gravel, add some water, mix it up, and then I could pour cement for a sidewalk or a driveway or something like that. So if I've got 175 kilograms of sand that I want to use it all up to make cement, how much gravel do I have to add? So again, this time I'm always have a consistent ratio of sand to gravel, which is 5 to 4. So this ratio notation, just another way to write a fraction. I know sand, so I'm going to put that in the numerator. I don't know gravel, that's what I want to find out, so I'll put g in the denominator. And then again, I can just multiply that diagonal. This is kind of a quick way to do a few algebra steps at once, and then I'm going to divide by 5. And so I would need 140 kilograms of gravel. Usually I worked on the page vertically, but just so it shows up on my camera, I just worked horizontally there. Again, it's nice because I can see my ratio that I've set up, what two quantities I'm comparing. I can see what exactly I'm typing into my calculator, and then I've got an answer with units. So just kind of thinking about how to communicate these solutions. The last question is why I brought this one up, this example up, is we've always been comparing part to part, or two different things, distance to time, sand to gravel. Sometimes instead we want to compare part to whole. So in this question, I want to know how much sand I need if I want to make 150 kilograms of cement. Well, cement is the total. So in this question, I want to know sand, and I want to compare it to total. So in each ratio, I'm comparing 5 kilograms of sand. I'm always using 5 kilograms every time I use 9 total, right? 5 plus 4 equals 9. So sand to total is always a ratio of 5 to 9. So if our total wants to be 150 kilograms, how much sand do I use? I'll use X for sand. And then again, I can just multiply the diagonal, 150 times 5, and then divide by 9. So we can also use this same approach to solve kind of part to whole ratio problems. So we could say, if I was writing a therefore statement because it's a word problem, I'd say, therefore we would need 83.3 kilograms of sand. That's about it for this video. I just wanted to show one technique to convert units using ratios and cross multiplying, and sort of extend it to solve all sorts of interesting real life sort of proportional reasoning questions. So that's all for now, and thanks for watching.